on my wrist, baby, make a wish. You could sell your Rari, but you can't afford my outfit. Versace on my wrist, baby, make a wish. You could sell your Rari, but you can't afford my outfit. Versace on my wrist, baby, make a wish. You could sell your Rari, but you can't afford my outfit. Versace on my wrist, baby, make a wish. You could sell your Rari, but you can't afford my outfit. Go wish. Go wish. Go wish. Go wish. On my wrist, baby, make a wish. You could sell your Rari, but you can't afford my outfit. Versace on my wrist, baby, make a wish. You could sell your Rari, but you can't afford my outfit. Versace on my wrist, baby, make a wish. You could sell your Rari, but you can't afford my outfit. Versace on my wrist, baby, make a wish. You could sell your Rari, but you can't afford my outfit. Go wish.
to go.
if you want something to hold on to, gotta find it first. But here I am, 'cause I've been laying under palm trees, waiting for the summer, knowing there's nowhere to go. 'Cause I am happy on this island, wanna be my farmland. I don't ever want to leave.
I wanna take it all in, I'm falling. The cityscape by night, wanna catch in my photos. Where you go, every corner twice as bright. They'll be my treasures forever. When I can't hold you tight, I'll see the Stockholm lights. The Stockholm lights, the Stockholm lights. Tomorrow feels a year away, like the seconds, the beginning and the end. But if in time it's yesterday, your picture's gonna bring it home to me again. The world is waiting up, the world is waiting half a step beyond our door. And if it's not enough, I wanna see the stuff the world has got in store. I wanna take it all in, I'm falling. The cityscape by night, wanna catch in my photos. Where you go, every corner twice as bright. They'll be my treasures forever. When I can't hold you tight, I'll see the Stockholm lights. The Stockholm lights, the Stockholm lights.
What's up, everybody? Good evening. The streams are starting later because the sun is setting later. And you know, the whole daylight savings time silliness. But that's cool. We're still here and getting the telescope set up. I am at the autofocus stage already. And soon we're in the right position to start the polar alignment. So this may be also the last opportunity we have for imaging for a while. Apparently we got some weather. Everybody kind of canceled, bailed on all the new moon trips this month. What's up, John Klopp? What's up, Mithridites Astro? And what's up, Brian the Primate? How you guys doing tonight? You guys got clear skies where you are? Myth said he had some marine layer, but it's moved off, so he's getting set up. That is very cool. Hopefully, it's kind of odd that you had marine layer that moved off. It seems strange. Usually the marine layer comes in and it's here to stay until the next day. But yeah, hopefully it stays clear for us. It should be pretty good tonight for me. It was freaking warm today. Like, I mean, it was like almost 90 here in SoCal. So, what's up, LTX Designs? Are you planning on doing any more SolidWorks tutorials in the near future? Yes, I am. Do you have any requests? Yes, I am. I have some sort of random skills in SolidWorks and to make videos on, and then also we kind of need to I want to continue with the series that I've been working on. So yeah, if you have any questions, maybe you have a model you're stuck with, yeah, let me know. And if you want to join the Discord, did I pin that? I usually pin the Discord message. Yes, there it is. If you want to join the Discord and chat about it in there, or we can chat about it here tonight while we're imaging. So hopefully, there's the telescope set up there. Oh, and it decided it wanted to look like that. So we are ready for polar alignment. Why is that not showing? That's weird. Oh, because it's over there. Duh. Okay, I'm focused and I'm ready for, yeah, stars look pretty round. Ready for polar alignment routine. So let's see, 5-second exposure, start from current position. Here we go. We will run this. Clouds, perhaps. Yeah, either way they're gone. Well, good. Yeah, I think it was like perfectly clear here all day. Super warm. It was like almost 90 here. How was it? Was it warm down there, Myth? And now it's like pretty warm in my apartment too. I've got like the fan on and the door open and the fan trying to blow some cool air in. It's nice out right now. So, and we were ready. Almost ready. So I'm going to switch mics here. Shorts and t-shirts and flip-flop weather, hopefully. Oh, shoot. Are we going to fail on the last point? Is that what's going to happen? There we go. All right, cool. Look at that. I'm pretty close. Okay, I will be outside. I have to close that. And then, so, I can't read the chat while I'm out there. Let's see. You have a model you're wanting to modify for an AV rack. Okay. Ah, well, no, not necessarily. Oftentimes you think something is simple. It's not simple. Do you have the CAD model already, LTX Designs? I'll be outside. I can't read the chat while I'm out there, but hopefully this won't take me too long. And then I just turned the headset off. I had it on. You hate your feet? Okay. I got used to wearing flip-flops, and now when it's any kind of warm outside, I just can't stand to have socks on. Hot, sweaty feet is just not a fun feeling for me. All right, I got to switch mics over. I will be outside. Stick around there, LTX Designs. Do you have an STL? Oh, okay, so not simple at all. Because now we have to do reverse engineering. But maybe hop in the Discord and maybe drop the STL in the Discord. We could look at it in a few minutes once I get the telescope set up. That might be fun to look at. So yeah, let me switch mics here, and not that one. No. All right, you should have me on the headset mic. Yeah. Okay, so I'll be outside. Just take me hopefully just a minute. Usually I can do this pretty quickly. All right. Let's see. I'm only 6 arc minutes of total error. Should have gone to the pool today. That's what I should have done. All right, let's see. Let's get the azimuth a little closer to start. I'm having a little bit of trouble getting solutions. Crap, might have to slew to a different spot and redo it. Hopefully not. Oh, no, okay, we're good. All right, we will move down. So yeah, if you have an STL that you want to modify, well, because it's not a parametric CAD file, you can modify it in a mesh mixing software, but that's it's not doesn't have the level of precision and control that you get from a proper parametric CAD model. So if you have an STL and you want to modify it, you need to convert it. Well, not necessarily. There's a few different workflows, but some manner of converting it to a parametric model. SolidWorks has a couple of different workflows for that, and they both kind of suck. So yeah, but we can definitely look at it. If it's not too complex of a model, it might be, the best bet might be just to completely remodel it from scratch, and go from there. Let's see, we are, oh my gosh, we are at 28 arc seconds of error. That is super duper dandy close. Let's see, I just made a little subtle tweak there. There we go, 17 arc seconds of error. That is a banger close. All right. Let's stop that and close that. Come back inside. We'll get the imaging set up. I'm going to shoot the Jellyfish Nebula again tonight. Going to get more data on that. I'm not liking what I'm seeing, but I need more data. Magistrix, I don't think we've seen you in a while. But also, I haven't really been streaming as much, so it's great to see our friend Magistrix here. And Misadventures, in Astro. Misadventures in Astro. I haven't seen any misadventures in Astro streams lately. Am I missing them, or have there just been none? Presumably because of weather-related reasons. Okay, 3MF is basically, I mean, it's the same thing. It's a mesh file. So, yeah. Yeah, just as complex to work with. Cool. Yeah, we'll take a look at that. Let me get my imaging routine set up here, and then we will. Then maybe we'll take a look at that. That sounds fun. You've been away and out of the country again soon. Oh, okay. Weather and life. Isn't that how it goes? All right, file, load image. I've really been liking the data I've been getting on the Jellyfish Nebula. It's just a faint target, and so I need a lot of data to bring that out. So, oops, I'm going to slew and center. I really wanted to slew and center and rotate, but we can do that. I guess we'll do that when it's done slewing and centering. And I'll bring up that image of the Jellyfish Nebula that I've been working on. There's an interesting star halo. This is like extreme haloing going on. So, watching Mars right now. Yeah, seeing is bad, and Mars is probably quite small now, I would assume, as it's moving away from us. Alright, I slewed and centered, but I didn't slew and center and rotate. What I need to do is hit the rotate button. And for this, I need to go back outside. And this should just take a second. So I'm not going to have the headset. I'm just going to go out and do that, and I'll be right back. Yeah, right on. Oh, shit. Yeah, 10 hours is what I got on the Jellyfish with my Rokinon lens. And that brought out a lot of good detail. So, I think I'm at 5 hours total on it now. I've been able to get 3 hours-ish a night. So, yeah, let's get this thing... Add this to the sequence here. I should have, well, that's an interesting, that must have taken an image while it was still moving a little bit. Yeah, that's looking more appropriately. Okay, let's see. Sequencer. And let's see. We will delete these things. Yeah, I'll delete that. Don't need these annotations. And I've been liking 240 second exposures. Delete that. And then let's loop. Loop until time. I think I can get this until right about midnight. So we'll just do, yeah, 2 hours and 38 minutes. And let's rock and roll on that. Yeah, let's see. Watch your Mars. Mithridites is 10 hours on the jellyfish. Went to the B2 site. Okay, yeah. Had bad weather. Oh. And wife got ill. That sucks. Getting her on the mend. Yes, yes, yes. Do not like being ill. Saw you updated the scope STL. No, I don't think there's only one part. That one part that had sort of major changes in the STLs for the scope. So if somebody did start printing it, they're gonna want to reprint that one. Anyways, it was like the wrong size screw hole. So the secondary mirror holder part. So not a very big part either. But I also added a lot of parts. To help make things easier. We were talking about this for Myth, that the section of the tube that you want to leave out so you can adjust the mirror spacing, and then the idea is that you change the length of that last ring section and print it yourself. Change it yourself and print it and put it in there. People may not have parametric CAD model tools available to them, so. We talked about this. So I generated like 12 different sizes in 2mm increments of that center section. So you can just measure it and then, you know, apply whichever one makes the most sense to your, for your scope, for your project. Yeah. And my autofocus is looking odd tonight. I don't know why. My focus has been really consistent and all of a sudden not tonight. So that's interesting. I think it's, yeah, it must be, maybe the focus motor is mounted a little bit loose or something. A little bit of backlash in there maybe. But I think it's still going to give me a good focus value here. I don't, maybe, yeah, maybe not. It could be a little bit, the focus motor could be a little bit loose. Maybe that's what's happening. And we are up and running. I'm going to check the guider here. I may stop if the guiding looks a little bit poor to start with. I might stop the sequence and adjust that and kind of restart. And the guiding is looking a little bit... Yeah, actually, I'm just going to stop. Because it seems like we need more settle time on the auto guider. It started out really kind of crappy, and now it seems like, okay, look, now it's settling. So rather than waste 4 minutes of an exposure, just stop it, wait a second, it's smoothed out, restart it. And just check over here. Stars look pretty faint. Maybe better off with 1 second exposures, but I've been running these settings like the last couple nights, so we'll stick with it for now. And we'll see what we get. Let's take a look at Jellyfish Nebula. Yeah, don't do a sacrificial sub. Just stop it. Don't waste that 4 minutes or 5 minutes or whatever. Stop it. Let your settling settle for another minute or two, and then restart it again. I don't have time for sacrificial subs. It's a serious business only. I'm loading PixInsight, so we're gonna get the live stack going. But we should look at the image that we're working on. Jellyfish Nebula. It is over here. So here is the Jellyfish Nebula. The rather unfortunate halo, which is mostly due to the filter. I'm thinking this secondary halo is maybe due to the reflections inside the tube. You can see these, you can see the 3 secondary mirror spiders, like shadows of them in this halo. So I'm thinking that might be reflections inside the tube itself. I don't have flocking material in the tube. I just painted it matte black. and maybe that's not quite as maybe it's a little bit more reflective than it should ideally be. This is one of those really troublesome stars. So your dither jacks up, you're getting from, yeah, so you need to increase your settle time, Myth. So check out your somewhere in your options, let's see, options, equipment, or it might be equipment and then guider. Let's see. Yeah, I've got minimum settle time 10 seconds. Maybe increase that to 30 seconds or more. It's a classic offender, right? We're talking about the star. So there's good signal over here. Some nice detail coming out of here. These sort of wavy bits of hydrogen. But the rest of the area is still quite... rest of this nebula structure is still quite faint here. You've got it at 45 seconds. So this is 5.5 hours of data. And if we look at this image, I shot this many months ago with the Rokinon 135 lens, and this is like 10 hours, 10.5 hours. You can see 10.5 hours. Now I'm really starting to get a lot more of this detail, this faint structure over here. And then see here, now we have the double halo. So this has a double halo, and this was a lens, so maybe it's not reflecting inside the tube on, with the halo on the other image. So there's like a double star here with this image. I never really was satisfied with this one because of these halos. It's just really rough here because it's covering the nebula. I never really liked that. So but it's not all stars. There's other bright stars, but that don't have this double halo. The bright stars in Orion don't quite do that. Like the Horsehead Nebula. Let me bring Horsehead Nebula shot up. So this one's better. So this star is probably brighter, or just as bright, if not brighter. And this doesn't give me this like double halo, so I don't know why I'm getting it with, why that star. I don't know. I'm sure it has to do with a combination of the, of the filter and maybe the actual like the color temperature of the star, what actual kind of star it is. Stars have different wavelengths, so yeah. What's up, Chris Archer? How you doing? Thinking about trying to image a Horsehead tonight? Yeah. I can get around 10 to 15 second exposure to f8-ish. Oh, at f8, you're going to need a shitload because that's so slow, right? The amount of light getting in is just so little at f8, right? So, yeah, go for it. It's a bright target. There's a lot of stuff in there. So, with your crappy 300 millimeter, the field of view is probably wider. You can probably get like all of Orion's belt in there. And so I have this shot. I really like this shot. This was with my Rokinon 135 lens. So here's the 3 bright stars of Orion's belt with the Horsehead and flame in there. So I would try to frame it up like that. Okay, Bordeaux 5.6. That's definitely better than what I've got. But even still, at f8, it's so, yeah. It's like each f-stop is like half the amount of light, right? And so I'm shooting like f4, like f3.75. This was shot at f2.8. So, that's awesome, LTX Designs. Yeah, we're kind of this mix, right, between like design, manufacturing, building stuff, and astronomy. So sometimes I stream like pretty much just CAD stuff, like working on telescopes, and tonight's an astronomy night stream, but we can mix it up for sure. And we've got our first image and almost a second image. I would definitely recommend it. Definitely, yeah, be careful though, because it is a rabbit hole. So first image is in, and the stars are round. I'm satisfied with that. The stars are really looking really round on there, actually. That's a... No sacrificial subs here, Mithridite. A lot of sky glow, though. So, and you can see one sub is just super faint. But this is a fun one to do the live stack on, because it really, after an hour, we really start to get, you know, some data brought out here. So let me get the live stack set up. Chris Archer, do you have, I think you were talking about, do you have step rings for creating an aperture mask instead of stopping down the aperture? So like, you can use like step rings on the front of your lens. I can't remember if we talked about that or not. Because maybe you can run that at a little bit higher focal ratio. And yeah, okay. The live stack is starting. Get that going. Guiding isn't looking super awesome tonight. Kind of an interesting amount of sky glow I'm seeing in here. It might be kind of hazy still. I think the transparency and the seeing are gonna come and go a little bit tonight. So. All right, we just pretty much got set up at the same time. Awesome, dude. And me and Mithridites, our two image scales, we have two very different image systems. But the scale that we have, the field of view we have, is very similar, so it's fun to compare. All right, let's take a look at... let's take a look at this file that our new friend LTX Designs shared. And talking about modifying a design here. Always at least antivirus scan things that people send you over the internet. All right, that looks probably okay. Okay, let's get this out of here. Ah, gotcha. Well, you'll still want to do something similar with the Rokinon lens. I have an aperture mask for that as well, so you can run it about f2.8 without stopping it down. Because if you stop it down, then you get diffraction spikes. So. Okay, so let's see. So this was what we were talking about. You wanted to modify, right? This looks interesting. So there's a little snap connector. So this looks like this goes in here. So you can like put two of these together. What was it again you wanted to do with this thing, LTX? It's kind of a lot of features to try to, you know, recreate it from scratch. Definitely that could be done. Oh, are these Apple TV holders? Is that what that's what these cavities are? So Apple TV slides in there? I guess that's about that size. Make one side hold two Apple TVs. Yeah. Trying to think like what the best, you know, like workflow for that is. It kind of depends. Fusion 360 has a pretty good STL conversion. It would probably work fine with this file. SolidWorks just it kind of does it. Gotcha. Cool. What's that for? Is this like a server rack mount for Apple TVs? I think, let's see, can we? Yeah, I think I would just model this from scratch, honestly. Yeah, because so Prusa Slicer has, I'm using the measure tool, has a measure tool, so I can measure these dimensions. And yeah, I think I would just model this. I would just start over. It's not too complicated to do that on this part. It would be easier to just model this from scratch, or to just basically copy this and remodel it, than it would be to try to modify it. Yeah, right, got it. Yeah. Yes, I would just measure it. So I'm using Prusa Slicer, but I think most slicers have equivalent functionality these days. It has a measure tool, so I can measure these dimensions. I wonder if it will. Can I get? Yeah, so I don't know if it's going to recognize this as a. Yeah. A little tricky to get these radiuses right. So probably what I would do is I would import this into SolidWorks, and then basically kind of trace it. You know, like you can measure the dimensions in here. So for example, this inside width is 95 millimeters. Yeah, 95 millimeters. Yeah. We could, yeah. That could be a good, yeah, reverse engineering stream. Yeah, that's like a daytime thing. CAD streams are like for the daytime, right? That's like a daytime. So maybe tomorrow during the day we could do that. But yeah, I think that's what I would do on that part. Do you need this little hole here? Oh wait, you said no. You don't need the keystone hole. The keystone that's a keystone port there. Yeah, right. Gotcha. Yeah. You don't need this joining feature, though. That's true. Yep. We can't astronomy during the daytime. Unless we're doing solar astronomy, which I'm not. I don't have a solar scope. That would be a lot of gift subs to get a solar scope. But I don't know if I really want a solar scope. It could be interesting. There could be really cool stuff to see. How are we doing over here? We're on the 3 exposures now. Let's zoom in, take a look at the star shapes. And those are looking very round. In my image history here. Very round. Okay, I didn't want to say anything before because I didn't want to jinx it. But I think like I'm at that stage with this rig where like everything is kind of just working. Like I like the last several sessions in a row, the last 4 or 5 sessions in a row, I'm able to put the rig down on the balcony, set it up, and be imaging in like 15-20 minutes. I'm satisfied with the collimation. I'm satisfied with the mount's guiding performance. The mount's guiding performance has been pretty good. I'm satisfied with the star shapes. They could be better, but I think they're pretty good. And it's been consistent. Like the last several nights that I've been running this, I've only thrown away a couple of exposures. So it's been running, everything has been pretty great. Part of that is because Dan, our friend Dan, donated this this new tripod. Well, new to me. Very used, very old, very well kind of beat up. Proper astronomy tripod. So much more rigid setup. Definitely helps with the consistency. I think it's a major part of the consistency. And so yeah, I'm very pleased with how the telescope's been, the telescope and the mount, the whole imaging rig, the way it's been performing. I'm like finally at that stage where everything is yeah, is working pretty good. So the last few sessions, astrophotography has been boring, which means it's working good. And the live stack here is 4 images. We're starting to see more detail come in there. Ah, yeah, I probably would too. Yeah, so I'm guessing that this part is just split up like that because you would not very many print beds that you could print something that long on. Yeah, that snap's probably not the most accurate thing. It'd be fun to give that a try though. Yeah, it probably doesn't hold it that securely. I would probably glue it together, honestly. I would probably use that snap, but then just put some glue on it to hold it together. Yeah, that could be pretty straightforward. Let's time to get a second rig. I don't know. I don't know about that. I don't know about that. I kind of sort of thought about it. I have let me show you what I have. So I have this little guy. I made a YouTube video about repairing this thing. This is the oh wow, it's heckin' loose too. Why is that loose? This is the Skywatcher AZ GTI, which is an alt as mount. So you can't really do imaging with it, but it supports and it has the firmware has an equatorial mode, so you can run this thing in equatorial mode. However, it does not have a USB port for connecting it to a computer to like run Nina. It does have a, you know, the old phone jack hand controller port, so you can get a device that gives you a USB input to the hand controller port thing and control it that way. And I was looking at that, but the support for that seems to be like finding that device first of all and then getting it to work right. It just seemed like it's not worth it. So yeah, this thing is just kind of collecting dust. I might sell it if anybody wants a Skywatcher AZ GTI. It's a good little mount for a small telescope. You know, little go-to tracking mount. So, and it was damaged, but I repaired it. So it does have Wi-Fi. It does have Wi-Fi Magistrix, so maybe you could connect to it through Wi-Fi to control it through with Nina. I didn't think about that. I didn't think about looking into that. Maybe that's something that'd be worthwhile. Yeah. Oh, you're looking to a printer that can print in one piece. That would probably be a giant printer. I think that's probably not something you're gonna find. Yeah, the Star Adventurer GTI. Yeah, that thing is those things I think are probably pretty great. Yeah. Yeah, Chris. Yeah, this thing just doesn't have the so this it would need a wedge, and I was going to design and build a wedge, like a 3D printed wedge for a small scope, like a small rig this size. A 3D printed wedge would totally work, and I could put my Rokinon lens on here. I think that would work just fine on here. But oh shit, RatRig has a 500 millimeter printer? That's massive. Somebody like the monitor I have my camera mounted on is like wobbling. Looks like an earthquake going on. Yeah, yeah, light portable gear is nice, isn't it? Isn't it? So, I got 5 exposures now. How are we looking? How are we looking? We 5 for 5? Oh, yeah, that's nice. So one kind of way you can tell is there's sort of separation. There's like probably a binary star here. And very round, and there's a little bit of separation there. So decent star shapes, decent seeing, I guess. And 5 for 5. Pretty good. They do sell a wedge, Chris. You're right. Yeah, part of it was the part of the part of the impetus for the project was like, okay, I'll design and build a little wedge that we can 3D print, and it'll probably still end up costing you about the same amount of money because you need to buy shafts and bearings and stuff. But yeah, the lack of connectivity was what stumped me on that project. So the live stack's coming in. Oh, that sucks, dude. A little worse, I think. Star Traveler. I'm doing pretty good right now. Total error 7.7. I was around 0.1 earlier. I think. Actually, I guess that's maybe about where this mount runs. I've been consistently at, I think, averaging about 0.8 arc seconds of error. So right now I'm showing 0.7. It was like 0.1 earlier, so it'll probably go back to sort of alternate between 0.7 and 0.1. But I think the biggest difference in consistency is got to be the tripod. Much more secure, stable tripod setup now. So yeah, that's probably that's probably the main difference. Yeah. Most of the time, Chris, you know, when you do DIY projects, you're probably not going to save money compared to buying a commercially available product if it exists. You know, if it's a mass market commercially available project like a telescope mount, like telescope parts, you're probably not going to save much money, especially if you consider the value of your own time that you put into such a project. So, you know, I don't do projects to save money. I do projects because they're fun, and maybe they're. I mean, you know, they're a lot of the projects that I work on, I could save more money. Like they could be sort of more, I guess you could say, financially optimized. And if they're like open source projects that I release, I want that to be an option for people. So, but you know, I do projects because they will be interesting and fun, and interesting to me at least. So, you know, yes, I'm sure that the new tripod is significantly more sturdy. You can just feel it with the telescope on there. It's much more sturdy. So. A way to make a high payload mount that's 3D printed for relatively cheap. It's not the gearbox, Chris. It's the stiffness of the structure of the mount itself and the gearbox. But it's really the combination of those two things. And 3D printed plastic parts are just not stiff. So, yeah, DIY. I don't think a DIY strainwave drive. From what I've seen, I've seen maybe only one video of someone who's 3D printed a strainwave drive, and well, it worked because the flex spline was significantly more flexible because it's made out of plastic instead of out of steel. It had the effect of having backlash. It wasn't backlash. It was, you know, the whole flex spline flexing, but the effect was the same as backlash. So I don't think you were going to get any kind of payload out of that thing. So it may be possible to do a combination of 3D printing and some other composites type of stuff to get the kind of strength that you need. for the mount, it's for the mount structure, the mount casing, and the wedge. But yeah, the gear drive itself, I don't know. I'm never gonna say, I'm never gonna be I never want to be like a no, that's impossible kind of guy. But okay, yeah. Well, there's a lot of people that have built mounts that are using those. The payload capacity not very high, mostly because of the limitations of, we're using plastic parts for the structure. It's not the torque or the power from the motors that's the limiting factor. It's the strength and stiffness of the structure. I mean, we do need torque and we do need power from the motors, but not as much as what you might think. So, can we 3D print structure that's going to be strong like machined aluminum parts? No. But can we modify them to make them stronger? No, there's no plastic that comes anywhere close to... Well, okay, the only plastics that come close are like, really high-end stuff that would cost way more than to 3D print than it would to machine out of aluminum. I have tried some Fibron PPSCF. It's pretty nice, but it's not as strong as the... it's not as stiff or strong as the polycarbonate material that I use. It has higher temperature, but it's not as strong. And my saw a bit of a spike in the guiding there, so let's take a look at these exposures. And I think we're still okay. Yeah, this last one maybe not quite as good, but yeah, no, it's still acceptable, I think. Yeah. Small scale CNC. Also no. Yes and no. There are, there's like DIY CNC machines. Yeah. It's more than that, I think. Yeah. So there's like DIY and open source CNC mills and stuff. But the thing you have to understand about CNC machining is not just the machine, but the tooling that you need to do proper CNC machining can cost more than the machine. So, your end mills and your tool holders and your work holding vices for holding the parts to do machining. So, kind of yes and no. I don't know if I don't think Peak is impossible to print well. You just have to have a very capable printer. No, it's impossible to print well on a consumer grade printer. You need like a heated chamber that's heated to like 200 Celsius or something like that. Some crazy, because it's really high temperature material. It prints at like 500, and yeah, the chamber has to be like 2 or 300 C or something like that. So, and even then, I bet it's still probably challenging to print with. Yeah. Yes. Yeah. Set up gauge blocks, gauge tooling, measuring end mills. You're gonna break end mills a lot. Yeah. Machining is significantly more expensive, not just because of the machine itself. So, yeah, machine shops have a lot of that stuff, already, and yeah, it's expensive stuff. But, like a lot of things, if if sort of consumer level, machining becomes more of a thing, then, there'll be more sort of consumer level of that stuff available. And that can, yeah, and that can bring the price down. What's up, Mazif? Greetings. You guys, scopes set up for you tonight? 400C print temp, 140C chamber temp. That's lower than what I was thinking. I might be thinking of PEK. There's PEEK and then there's PEKK, and there's PEI. There's a lot of high temp materials. So yeah, that's pretty crazy stuff. So the thing, the M51 again, awesome. Very cool. Yeah, it's like the light pollution's so bad. I don't know. I kind of don't even want to. It's like it feels like it's not worth shooting galaxies for me here. I need to try the L quad filter. So I want to show an idea here. Let me hide. All right, talk amongst yourselves while I remember where this project is. I know where it is. All right, just give me a second here. Let me load this up. So we're talking about, like, can we 3D print stuff that's going to be as strong as machined aluminum parts? And I said no, but there are still some options. And I need to load this up. Here we go. You were looking at a DIY AM5 type mount. Yes, yeah. You're probably some of the guys in the Discord were talking about that, Chris. I can't remember. It was called like Hemi or something like that. Some guy has a really great design, a really nice looking design, and he has really good documentation for that. I'd have to look it up and find it, but yeah, oh yeah, they've been printing metal for a long time. Stainless steel, titanium. Yeah, no, you're definitely not doing that at home. Yeah, that's definitely not a home machine. So check out this part. So this is my current telescope mount, right? And so I made the pink and carbon fiber part. Let me open this up. Herm, yeah, I think that's it. Yeah. So this thing is the pink and purple bits are 3D printed, and then the other parts are carbon fiber sheet, and I think they're 1.5 millimeter. Yeah, 1.5 millimeter. So, so the idea here is you print this thing, you print these parts, and then it's like a sandwich structure, right? If I, let me hide some bodies here. So, hide, no? Hide. So see, we like have a plate on the bottom of here, carbon fiber, and then on the top and on the sides. So it's like a sandwich structure, and carbon fiber sandwich structures are very strong. That's where you can very much exceed the strength and stiffness of an aluminum plate, and be very mass efficient. Cool, man. Have a good dinner, Mithradites. Glad to have you here. So, now we can't 3D print carbon fiber, proper carbon fiber laminate, but, somewhat simple shapes, you can cut these out by hand with a Dremel. You can buy a sheet, or you can order these things CNC, or if you have a CNC router, a cheaper CNC router, you can cut carbon fiber plate like this. So I built this structure, and this thing is quite stiff. Now, is it as stiff as an aluminum, machined aluminum block? Probably not, but it's certainly up to the task for what I'm trying to do right now. And dinner's not till 11. Oh my gosh, I would die. That's right. You said dinner prep. Sorry, I accidentally a word. So yeah, this is definitely more complex than just machining an aluminum part. But it's something that I can build here at home in my apartment without a CNC machine. It would be better to have a little CNC router for cutting these carbon parts out. But I just kind of drew lines on it and cut it with a Dremel, and so it's kind of sloppy, the thing that I put together. But it works, and so. Do you think having RA and deck as separate bodies inherently reduces the stiffness as compared to having them in the same enclosure? I think maybe it kind of depends. I think maybe it kind of depends. I think having them in the same enclosure, like on the AM5, may have as much to do with manufacturing as it does with structural performance. You gotta keep in mind, commercial products are sold to make money. They're sold for a profit. And so keeping the parts down and the assembly so they can actually make it and sell it and make money on it. So, yeah, that may be as much about simplifying the construction for manufacturing as it is a structural constraint. So, yeah, I'm not quite sure. So here, I mean, all the bending load. So there's going to be a lot of bending load on the face of the RA axis here, and this could be better. Like this could be redesigned to be better with like an additional bearing to support it. So in that case, in this case, it's so there's less weight on the declination motor and axis, right? Because the gear drive and the motor for RA are over here. They're not hanging off of anything. So this is all fixed to the tripod, the wedge, right? So there's less weight on the RA motor and on the RA flange that's mounting to all the stuff that's mounting to the RA flange. We can look at that Herm mount. That guy has really good technical drawings. Nope. That brought up Ioptron. Oh. Oh, maybe that wasn't it. That's weird. There was a GitHub. Oh, Hemi. Yeah. It's this one. Yeah, it's this one. Not Herm, it's Hemi. Yeah, so this guy is just really, really impressive documentation on here. I'm kind of jealous of the amount of technical drawings this guy's. Takes so much time to put these together. See if we can get some more better view of it there. So yeah, so this is a similar construction to the AM5 mount, ZWO mounts. So let me see if we can see a pretty clever construction too. I like that he's using T-slot railings in here. So yeah, with this, you know, all the weight to the entire rig, telescope, camera, mount itself is all hanging on the face of the RA gear drive axis. Oh, yeah, I think I know which one you're talking about. I've seen that one, Chris. Yeah, I've seen that one. Yeah, I'm curious to see how that performs. I would not. I would be very surprised if, yeah, the 3D printed strain wave drive can support much more than a pound or two of payload. I would be very surprised. I'd be pleasantly surprised. I'm very skeptical, but I would love to. To see how that can perform. So yeah, this type of design, everything's all the weight's hanging off of the strain wave gear drive for the RA axis. So yeah, to me this looks a little bit structurally it looks a little bit, and the way he has this design, the wedge is narrow for adjusting the altitude and azimuth on here. It's narrow, and so I would expect that to be kind of a weak spot. It's a weak spot on my current rig, pretty narrow wedge situation. I would definitely like to see that be a little bit beefier. Would inspire more confidence for me. Yeah, this guy's got custom boards here and super cool stuff. Very nice. Very nice documentation. Very nice stuff. Yeah, that 3D printed mount. I wonder if we can find. That's on printables, right? I think there's so many. I have to go to printables. What? That's weird. Can't seem to find it on printables, huh? Keen 1. Is it on printables? Oh, okay. Yeah, this is the one I was thinking of. Yeah. All right. .3D printed harmonic drive mount. Yeah, she's got a 5-to-1 stepper motor and 78-to-1. Yeah. So the flex spline in here, I think, is the problem. Is the main problem. Yeah, and he even printed. He's even suggesting to print that out of TPU. So, yeah, that thing's gonna you're gonna be able to just twist that. I assume. He shows it with a very lightweight rig on here, so that's a little, and I mean, so. I mean, it doesn't. I'm in no way saying this thing doesn't have value or can't work. Like for lightweight rigs, like yeah, this could be really cool. And with small image sensor cameras, like the one I'm using, and like a Rokinon, the IMX 585 image sensor camera and a Rokinon 135 lens is kind of about that size rig. Like, yeah, maybe that could work pretty good on there. Yeah, I'd be interested. I'd be interested to see. I think it would be quite difficult to fine tune the fit of these parts, to have them be. Yeah, he went through a lot of prototypes. got some nice assembly instructions on this here. That makes me want to build one. I can definitely tell you that. I can definitely tell you that. You also, yeah, and I wonder how, you know, what kind of error you're gonna get with that. What kind of guiding performance? What kind of periodic error are you actually gonna get? Because we have significant periodic. That's the main problem with harmonic drive, with commercial harmonic drives, with, you know, proper strain wave gear drive units, is they have difficult periodic error issues. And so, you know, we're talking about a flexible 3D printed thing. Yeah, maybe even more difficult. Maybe better. Probably not. Yeah. Yeah, that's right. I remember you mentioning that. Yeah. I remember somebody mentioned that they started out, yeah. Yeah. Is it updated flex spline for this thing? I may have seen, looked up some of these before. From Luke 3D. Nope, not this one. Let's check on our... Whoops, yeah, there's the telescope. I meant to check on the imaging. How we doing here? Up to 12 exposures. And that's looking good. This one's a little not as good, but I think we'll save it. That'll stack out. I guess that's worth saving. Very good. Decent. Yeah, we're rocking and rolling. At Luke 3D on printables. Do they do, is it slash? Yeah, okay. Slash at username? Yeah, alright. Compact 44:1 harmonic drive unit. So there's something interesting going on here. His flex spline's got like a double... There's like a double gear on there. Well, that is interesting. Have you tried to print one of these? We'll watch this video here. It says at Luke 3D on printables. Luke_3D. I think when I was designing my telescope mount, I did kind of briefly consider, you know, trying to build my own harmonic drives, units like these, strain wave gear drives. But I dismissed it. And I don't think I regret doing that. Yeah, look at that thing flex splining and turning. It's really mesmerizing and cool the way these things work. I do think they are super cool. Interesting. Yeah. It's kind of fun the way the flex spline just kind of like marches along, you know. Yeah, cool. I think what I really want to see him do, though, is I really want to see like a backlash test, though, to see if you know, if there's flexing. Yeah, that was the limitation with some others that I've seen tested. So yeah, actually this video here. Yeah, this guy's video where he tests a strain wave gear drive and the cycloidal drive, and the thing was the flex spline itself flexes. Yeah. So the backlash. Maybe we'll just watch this part here.
Two gearboxes compared to each other in terms of accuracy, efficiency, and durability.
Yes.
Here on the left side is the harmonic drive, and on the right side is the cycloidal drive. The repeatability of the cycloidal drive is quite good, but once we apply a load, we can see how much backlash it has. At a distance of 15 centimeters, when applied force in both directions, there was around 6.5 mm play. On the other hand, the harmonic drive had the same good repeatability as the cycloidal drive. However, when force applied in both directions, it showed a greater backlash, with 8 mm play at a distance of 15 centimeters. If we observe the backlash in still position with applying just a little bit of force, then the harmonic drive was showing kind of better results. Here it felt like even there is no backlash at all, because even with the slightest touch, the output was giving some resistance. On the other hand, on the cycloidal drive there was around 2 mm of totally free play on the output, at the same distance of 15 centimeters. However, when applied a bit larger force, the cycloidal drive showed slightly better results, or 5.5 mm play, whereas the harmonic drive showed up to 7 mm of play. Let's take a look at the torque outputs
so
now.
Just like right there, I mean, you can see how much he's able to push that.
The output was giving some resistance.
Yeah, see how much that moves? Like, so that's not actually backlash, it's the flex spline itself flexing. And I thought he
The flex spline, a bigger and longer one, which means that the...
Yeah, so he only has two. So yeah, okay, so it had none. All right, well, yeah. Yeah, this was just one video one design, one video, right? So, yeah, cool. It's all fun stuff. How we doing over here? Looking pretty okay. I think there's this kind of white sky glow here. I think that was not present in my other images on this target. So, yeah, this may introduce some gradients that may be difficult to remove. So, it is loud. You're right, because we were watching that video and I forgot to turn it back down. So thank you. Yeah, I would love to image this without this filter and see what this star halo looks like, or with a different filter. See if we could, you know, reduce that. Guiding's still looking good. Yeah, I haven't thrown away any subs yet tonight, which is reassuring. So I did update the telescope design a little bit. I think maybe now is a good time to talk about that. Version 1.2.2, I'm calling it. Let's load it up. Don't discard. I don't want to save any of these changes. Finally starting to cool off in here. It feels like kind of nice and chill now. So no major changes, mainly just kind of correcting some problems with this design. The secondary mirror holder part, this center screw was set up for like an M6, and I changed it to an M5 when I first built it, and I forgot to change this part. So this was fixed. This is fixed now. And I had to remake that part myself, so I fixed it when I remade it. And then this part. So the idea with the scope here is this is in two separate parts. And when you're building this thing, the idea is to leave this section of the tube out. I can actually show that here. So the idea is to leave this section of tube out so you can adjust the distance between the primary and secondary mirrors to get the focus in an ideal spot. And the ideal spot of the focus is somewhere where the focus or draw tube is not protruding up into the light path. So that's the reason for, you know, maybe needing to be able to fine tune that, because you may be using a different focuser, since this supports different focusers. So the idea is you build a telescope like this, you go out, you get the focus set right, you measure this distance, and then you modify this part. You modify this part to fill that gap. Maybe it needs to be a little longer, a little bit shorter, right? But it was pointed out to me, because sometimes I need things pointed out to me. Not everyone has CAD software and, you know, kind of has the ability to knowledge or skill of being able to change that part. It's just changing the length, but it's a simple change to make, but still it's a barrier to entry, and I want there to be as few barriers to entry as possible to, you know, a project like this. So I went through and I generated STLs for all these different sizes. So what do I have here? I have like 12 different sizes. So those files are all available now. So you can measure that distance and then just pick whichever one is the closest size that you'll need. Everywhere from 34 to 56 millimeters. So that's included now. And then updated the documentation a little bit on here. Just kind of every time I load this document up, I look at it and it's like, oh, I should include this little bit of info, or maybe somebody's asked about something. You know, so I want to, you know, include some more info on there. More notes about the assembly. And so yeah, that's what's new. Yeah. Well, you know, like I said, you know, I want this project to be something that you know, others can pick up and build and, you know, not have excessive barriers to entry. I don't want to be a project gatekeeper, you know, like, oh, you have to have SolidWorks to be able to build this telescope. Like that's lame, right? I don't want to be like that. So yeah, I think I probably, well, GT2 belt drives are the best cheap low backlash 3D printed trackers. Probably, yeah. I think you're probably right. The only thing that it would be neat to compare would be a 3D printed herringbone gears. I use a lot of herringbone gears in the stuff that I build, Chris. So it'd be nice to see like which would be better, 3D printed herringbone gears or GT2 belt drives. I think the herringbone gears could probably be a little bit more rigid. Well, I don't know. A proper belt drive can be super rigid. So yeah, yeah. Do you have your rig set up tonight, Chris? I think you said you're in the Bay Area, right? How's the skies up there tonight? So that's the changes and updates to the telescope project. I have another thing. I don't know if I really want to go down another rabbit hole with this, but I did find something else. Maybe we'll talk about it in a minute. But yeah, I think the only other design change I was gonna maybe make on here was add a port for a fan on the back. I haven't needed that myself yet. Others might. It would be nice to have the option. I think that's probably a feature that we might want to add. So I think that was like the only other thing. Oh, cool, Chris. Yeah, right on. Looking forward to seeing what you were able to get. Oh, a secret project. Ooh. Well. Guys, I gotta take a piss. Let me, you guys watch my, you wanna watch the guiding graph or the live stack? Oh, yeah. Well, I don't know how it's such a nice night here in SoCal. So it would be a very pleasant night to be outside in SoCal. I don't know how it is up there for you. I gotta take a piss. Yeah, I will. I'll be right back. Oh. The Robert Ferguson Observatory. I don't know what that is. Let's Google that. Looks like it's a city-owned thing. Ooh, I think we got our first throwaway sub here. Yeah, this one's bad. Thumbs down. I don't like it. I don't want it. I don't need it. Kind of got a couple in a row there that are not super great. Hopefully that trend doesn't continue. Might have been a little spike in the guiding that we didn't see. First time up there. Okay, we were looking at Robert Ferguson Observatory. Let's see what we got going on. What they got going on there. We have to hide that. So it looks like the city of Sonoma owns it or something. It's that when I googled, this is what it brought me to. Observatory is to give the public a place to foster their interest and passion in astronomy and space, inspire young people to pursue STEM, blah, blah, blah. RFO offers public star parties, holds private observatory events for scout schools and other youth-related nonprofits, does outreach for schools. Very cool. Young Astronomers Program. The observatory houses a 40-inch reflector telescope, the largest telescope in Northern California. That is very large. A 40-inch telescope? Wow. A robotic 20-inch research-grade CCD telescope, and an 8-inch, 2-meter-long refractor. Oh wow, big wow, they have a lot of stuff up there. There's a lot of telescopes. Is that really all that's all they have on their... This is the website? Oh, there's another. Here we go. Wow, very active list of websites with oh, and they have the forecast on there. Yeah, telescopes. What do they have there? Ooh. Look at that. Big Mama. 40-inch f3.6. God damn. Let me have that. Oh man, that's got to offer some pretty sick views. Oh, cool, Chris. Okay, then they got a big old refractor in there too. That's awesome. Some solar scopes. Yeah, very cool. Yeah, right on, dude. For sure. Rent the observatory. Wonder what kind of skies they have there. Let's map it. Do they have directions or visit? Directions. There we go. Robert Ferguson Observatory. Zoom out. Near Santa Rosa. I've been to Santa Rosa. Yeah, so north of the Bay Area. So maybe that's like Bortle 5 or 6. Let's try a light pollution map. So So it looks like it's definitely east of Santa Rosa, kind of just straight east of Santa Rosa. And where is near Mount Hood? Is that? Why do we not see? Oh yeah, St. Hela. Yeah. So it looks like it's in here. Yeah. So what's that on the Portal 4? Ah, pretty decent skies there. Yeah. Oh, right on, Chris. Yeah. Yeah, so Portal 4 skies there. So yeah, you know, pretty decent. Pretty decent. Definitely significantly better than where I'm at. A little bit farther north and you can get to like Portal 2, Portal 1 2. But yeah, these guys are probably getting encroached on, you know, more and more light pollution as these areas, you know, build up and develop. You know, I bet 20, 30, 40 years ago, that was probably pretty really dark there. So, but yeah, that's super cool. I would definitely love to go there. What kind of events do they have? Public star parties? Upcoming public star parties. March 29th, this weekend. April 26th. Cool. That'd be fun. That sounds dope. Looks like my imaging after that really bad sub had decided to autofocus. So yeah, it's autofocusing. Oh, okay. Cool. Yeah, take your rig up there with you. When are you doing? When are you going up there, Myth? Just next time you're up there. Here's Cheg's Astro Tracker that he designed and built. Chris Archer. I love the simplicity of this thing. Possibly end of May. Cool. Yeah, I love the it's just a few parts, right? So I definitely dig that. That's cool. Ah, yeah, cool. Right on. Yeah, end of May. So that's about the May new moon, right? So hopefully they have some nice dark skies up there too. So I recently visited an observatory also. I'll share some of these pictures. Over the weekend, took a day trip up to the Mount Wilson Observatory just to check out the grounds, check out the telescopes. This is the historic 100-inch telescope. So 100 inches in diameter mirror. That's pretty big. And look at the chonky hardware to mount this thing. It's like a fork mount. It's kind of interesting. You can sort of, they have this like public viewing window. It's like a side window in the building, so you're like in the building, but you're like separated, so you're not actually like in the room with the telescope. There's glass, you can see like a reflection. So you can just go in there and view it, and probably hard to get a sense of scale for how tall this thing is. That's the secondary mirror at the top there. I don't know if you can see that very well, but that's the secondary mirror. And so down here, I'm pretty sure this white scope is like an 80 millimeter refractor. That's the eyepiece. So they have like an 80 millimeter refractor to view, and then I'm pretty sure the light, it bounces through some mirrors in these tubes here to get the eyepiece down to the bottom down here. So cool, Chris. Good luck, man. Looking forward to seeing your results. And my thing just got done autofocusing and is back at imaging and looking good. So that's the 100-inch telescope at Mount Wilson. You can view it during the daytime like that. And then, let's see, I posted some more pictures of this very beautiful spot. So that's the building, the dome. Impressively large building, especially considering the thing is, it's literally almost 100 years old. I think it opened in 1917. Giant shutters there, you know. And the whole area is just it's really beautiful. It's like a big campus on top of the mountain. Yeah, so it's like this big, like, I guess campus is the best way to describe it. You know, you walk in there and it's, you know, it's on top of the mountain and it's like in the woods, you know, so it's shady, it's in the shade and you know, there's views because it's on the top of the mountain, and it's just really, really beautiful up there. You have to like walk, you know, you have to like walk in there, sort of like an amusement park almost, the way it's, you know, the sort of the ambiance, the feel, it's kind of like that, you know. So and then there's a bunch of telescopes, right? So there's the 100-inch telescope and a 60-inch telescope, and there's a couple of different solar telescopes, and then there's some other telescopes they're doing like active research with. So yeah, there's a lot of stuff up there. And they have yeah, so you can book, let's see, 100-inch telescope reservations. Let's make a reservation. $2,500 for half a night. That's cheaper than what I remembered. For a group of up to 20 people. So I don't do math in my head. Well, that's only $125 each. So chat, let's get together. We could organize a trip, reserve a night. We could go view, you know, go use a 100-inch freaking telescope. "20 minutes after sunset to 1 a.m. Like, that's probably enough time. Even in the summertime, when there's not as much, you know, when there's not as much nighttime, dark hours. That's still, I don't know if I would want to be there for the full night. Probably I would, though. Yeah. Yeah. You know, bunch of issues. April 1st, we could go. April 6th, available. Ooh, they have a PDF about photographing with the 100-inch telescope. Should I bring my camera? Wow, they're literally talking about. They're literally telling you like how to. Yeah. How to hook your DSLR up to the telescope. That'd be so sick to get up there and you just like use Nina. like put my little mini PC on the telescope, you know? That'd be such a fun video. Like YouTube video. You know, like what telescope do you have? You know, just put my little same camera I'm using now on there. That'd be insane. Just to get like a few subs, right? Few sub exposures. Nothing. Not trying to like, do a whole lot of crazy stuff, but yeah, that'd be insane. Yeah. There you go. Yeah. Yeah. Yeah, that'd be wild. So that's the 100-inch telescope at Mount Wilson. For those of you guys who don't know, the significance of that telescope, yeah, you get like a section of the jellyfish. Oh, wow. And then there's a good... You think there's light pollution up there? This is the live webcam right now. That's, this is where I'm imaging from, guys. This is, yeah. That is, yeah. A little bit. Oh, cool. We can see Orion in the webcam. That's cool. You see that? I'm trying to... Yeah, that's Orion's belt there. And there's the Orion Nebula. Look at that. Yeah, right. Great Basin Observatory? Yeah. Oh, images and data. Oh, there's a lot of stuff up here. Yeah. So, yeah, the 100-inch telescope. See if I can... Oh. This telescope, the historical significance of this telescope, I think I said it became operational in 1917, and for like 30 years or so, it was the largest telescope in the world. And this is the telescope that Edwin Hubble used in the 1920s to discover that our galaxy was not the only galaxy. Prior to that knowledge, galaxies in the night sky, they didn't know they were galaxies. They called them spiral nebulae. Because in the rudimentary imaging that they had at the time, and you know, to your eye, looking through the telescope, they looked like, you know, they looked like gray clouds like any other nebula, but some of them have these distinct spiral shapes. And they didn't know that those were whole other freaking galaxies. They just assumed they were other nebula like the nebulas that we see. And so the simplified version of the story is Hubble discovered a Cepheid variable star. Not sure if I'm pronouncing that correctly. A variable star in the Andromeda galaxy. Andromeda Spiral Nebula, they call it at the time. And the significance of those stars is they like pulse with a certain unknown brightness. And because of that, you can measure the distance to the star. And they measure the distance to that. You measure the distance to that star, and it was way farther than anything else they measured the distance to before. And that led them to the conclusion. Yeah, Cepheid variables. Yeah. I think I actually have an image of that. Yeah, okay, yeah, check this out. So, 6th of October, 1923. So this is Hubble's plate. Photographic plate. And so he says he wrote Ver on there with an exclamation point, that little star there. And so this is and I overlaid that with my image of the Andromeda Galaxy, and I'm pretty sure I got it right there. So kind of cool to see, like, from my backyard to get the same, you know, this was with an 8-inch telescope, a little bit smaller than a 100-inch telescope, but, you know, anyway, so that is cool. So yeah, 1923 is when we learned that the universe is larger than our own galaxy. Significantly larger. Like, that means the universe is like way larger. A rather incredible discovery at the time. Information that we take for granted now. It seems wild how much our understanding of the universe has changed in only about 100 years. The most recent 100 years. To think that in 1923, a little over 100 years ago, we didn't know that the universe was anywhere near as large as it is. And with this discovery, the universe became, like, beyond exponentially larger than what we thought it was. Yeah, Henrietta Leavitt, that's right. Yep. Yeah, she discovered the Cepheid variables. Yeah. Yeah, right. A theatrical play. That's interesting. I'm pretty sure there was some shit with Henrietta Leavitt that, like, you know, she was like a female astronomer, and so, like, you know, there was like some male astronomers that, like, took credit for her work and then probably wasn't actually credited until later, like after her death or something like that.
Yes, science.
Yeah, science indeed. Yeah, she discovered the period luminosity relationship for Cepheid variables.
Many people feel small because they're small and the universe is big, but I feel big because my atoms came from those stars.
Yeah, Cepheids were soon detected in other galaxies such as Andromeda, notably by Edwin Hubble, 1923-1924. Leavitt's discovery of an accurate way to measure distances on an intergalactic scale paved the way for modern astronomy's structure and scale of the universe. Well, there you have it. Oh my god, Wikipedia has a dark mode. Alright. Have you guys donated to Wikipedia yet lately? This is the first I've ever seen this on Wikipedia. On the right over here, this bar. To be able to change these text size and stuff, and then they have a dark mode. That's like the first thing that makes me want to actually donate to Wikipedia. Now they have a dark mode. I dark mode everything, but my own website, I don't have a dark mode on my website. This just really bothers me. I mean, my website's like, it sucks. Yeah, no, my website sucks. I hate doing websites, web design, web development stuff. It's WordPress. WordPress can be freaking lame. And, I've been trying to find like some WordPress themes that have like a dark mode that I can use, and like, it's just, I don't know. I need to do something different with it. But at least the information's there, so some of it is. I need to work on this a little more. I have like astrophotography on. These are like old astro images. Some of them are pretty good, but I've reprocessed these. They're way better now. And yeah, I don't think I get a lot of traffic to my website, so like I don't really care, but I do need to just have like some place that I can direct people to, you know, so it's like just, you know, go to my website and then, you know, follow the link to printables or whatever. So, but yeah, I'm dark mode everything in my life, but my own website is not dark mode. So that kind of bugs me. But now Wikipedia now has dark mode, so I need to get on that because Wikipedia, yeah. Awesome, Mazif. Yeah, you were having issues with, what were you having issues with? I forgot. Star shapes and aperture. You're not the only one that's been having issues with that. Here's an update on our live stack. Up to 22 images. Everything. Yeah, this is what it looked like the last few nights. Stars are trailing a little bit in the live stack because there's one image in here that I threw away. Let's check our most recent images. Guiding looking a little bit poorer now. But still getting pretty decent subs here. Yeah, let's take a look at Mazif's little 50mm rig. It's in here somewhere. Wait, is it in here? Yeah, here you go. Rokinon 50mm, right? Right, Mazif? Super tiny little cam. Kind of doesn't get much simpler than that, does it? And then we don't see the rig in there, the mount. I know you posted that somewhere. I'm trying to look in the Discord to find it. Right on, Myth. Trying to find the kind of the full view of Mazif's mini rig here. Flaming star and tadpole regions. Yeah, so you get some spikes on the bright stars there, right? But I mean, this is pretty low resolution. But yeah, no, that's cool. Cool field of view. Be fun for those North American nebula type stuff. Your mount has a warm up. Yeah, we got to figure that out, right? Like why are we? Yeah, why does it, you know, start out poor? Yeah, here we go. Yeah, so just kind of a pretty minimalist little rig. Looks pretty tall and lanky. But yeah, look at just one cable. guess you just manually turn the deck to get it pointed roughly where you want it to point. That's really cool. I think I had one of these mounts, one of these Skywatcher mounts. I had a little Star Trekker kind of thing. I'm not sure if it was that one. I had something like that. Yeah. Yeah, I dig it. Yeah, myth. We gotta figure that out. Like, why are we getting like, yeah, that your mountain has a warm up period? I mean, maybe it's just coincidence. You know, it was working poor and now it's working better. But, and I mean, I know what you mean. So, like, it should definitely, you know, it should definitely work. Like, I wonder if there's like, you know, as the target gets lower on the, as the target, I mean, maybe there's like a backlash or a balance issue, and as the target gets lower in the sky, that, you know, the you know, the loads change a little bit. So, skill issue, yeah. Yeah, I feel you there, Mazif. Yeah, you could just put a DSLR on there, especially like a lighter, you know, smaller, lighter DSLR. I think the decent Astro cameras these days are pretty affordable. Not much reason to Astro mod a DSLR. From what I can tell. Maybe that's not true. I suppose if you already have the DSLR and you don't want to spend money. Yeah, we should get oh, we could do May 4th. Go up there on like a new moon night. Yeah, full frame. May the 4th be with us. What are we looking at here? 24 images now. What, I don't math in my head. 96. A little over an hour and a half. Should we go up there on Star Wars Day? So I wonder if I'm going to be able to get, you know, much more data, you know, much difference in the data on this target. So I did shoot. I have 2 nights on this target so far, and this is my processed image from the first night, and so that's 2.5 hours. And then this is the second night, 5.5 hours. So 3 hours more data. And I'm toggling between them. And the processing is a little bit different on the two. But, I mean, if there's a difference, it's super minimal. So the difference between 2 and 5 hours, not really seeing much. So after tonight, if everything continues to go good, we'll get it to 8 hours. So will we see a difference between 2 and 8 hours? Guess we'll see. Yeah. Yeah, you posted that. Really? So Cygnus Wall is up that late, early in the morning? That you're able to get some time on that? Load Stellarium up and take a look. I seem to remember kind of on one of the streams earlier looking at this and just thinking like it wasn't going to be anything Milky Way core was going to be not available until later in the year. Yeah. Well, especially the time, right? Not ideal. So, let's see. Oh, okay. Yeah, so you're looking like North American Nebula region, and so at 4 o'clock in the morning. Yeah, 4 o'clock in the morning, it's 28 degrees altitude. So, yeah, definitely not there yet. I don't get it, from out behind the tree until, quite a bit later. Be like 7 a.m. So obviously the sun will be up, by then, but looking forward to pointing my new scope at that region again. When will that be? Like the Satyr region? We set the time to like 1 a.m. and then we can just move the month, advance the month. Let's see. So it looks like not till June. Not till June for me. August for Satyr, yeah, probably. 1 hour of data and Border once, yeah, it's 27 hours and yeah. Yeah, June for me when it clears the trees, my trees, the trees, massive. So I hope I'm still living here in June. We'll see. But talking about the scope, I did want to kind of look at something in a minute because after I take a piss, because I did find another mirror on AliExpress that I'm interested in. So let me go take a piss and re-up my water. So I'll be right back. You guys can check out. Do you want to watch the live stream or do you want to watch the telescope and security cam? Or do you want to watch the graph? A new mirror, yeah, a new mirror. Talk about that in a sec. I'll be right back. All right. 24-inch mirror in my dreams. No, we're gonna get a 100-inch mirror. Damn, that would probably make a sick YouTube video, dude. Going up to Mount Wilson and doing astrophotography with a 100-inch telescope. Because you could totally just... You could totally just... all I would need would be my camera and... you know, various adapters, and the camera, various adapters, ring adapters, maybe the filter drawer, maybe the filter, and the mini PC, and then a battery, and my tablet. Yeah, maybe a light pollution filter. Because there's light pollution up there, right? But I think it would... I mean, if they're talking about putting a DSLR on it, then like putting a little AstroCam on there, you know, should be like not a problem at all. And you know, just get like a couple of subs, like not even really like. You know, you're not gonna like actually image all night. I mean, you really want to, you know, view it through the eyepiece, right? But yeah. Depends on the time of year that we would be up there. I mean, whatever, you know, planetary nebula. Maybe planets, Jupiter, they're probably gonna be gone. I mean, it depends on the time of year being up there, right? Yeah. Would let the telescope operator, you know, tell us what's good to point the telescope at. But that could make a really fun YouTube video. Like, hey, you know, we went up to the Mount Wilson Observatory and this is how we did that. And, you know, we took this little camera and we put it on this gigantic telescope. That could be a lot of fun. Yeah, whatever's high up. I don't know. Anyways. Oh, so we're talking about other mirrors, right? So I found another mirror on AliExpress. Trying to get this loaded up here. Hide that. Yes. Yep. And you won't believe what you saw. So 130 millimeter, 520 millimeter focal length. So just a little bit bigger than what I currently have in the 3D printed telescope. It's a bit pricey, $182. But I think this is really kind of the ideal size. I think there's a big limitation to the 114 millimeter, 450 focal length, and having a little bit longer focal length. That's 70 more millimeters. And focal length makes the mechanical size of the telescope, or mechanical design of the telescope, much better. This is it's 130 millimeter. So currently I have 114. So I don't know if I can, we've talked about this many times before, but let me bring up the section view and we'll look at one of the main limitations. It's a little bit more than 5 inches. So this sketch that I have overlaid, the main limitation in a small Newtonian telescope like this really is the length of the coma corrector, which is, most coma correctors are pretty long, about 80 millimeters long. That's what I have drawn here. And not only the length of the coma corrector, but the length of the coma corrector and then the back focus distance from the coma corrector to the image sensor, which is another 56 millimeters. So we need that much length sticking out of the telescope, out of the tube, which limits the distance between the two mirrors to get the total focal length distance from the primary mirror to the secondary mirror and then down to the image sensor. If the coma corrector could be shorter, then the camera can move closer and then you can spread the mirrors out. Yes. So yes, Massive. So with this scope design, the Batter MPCC could be better. Yeah. You're noticing dimming on your images. Yeah, let's there's my most latest one, and let's look at the first one. Yeah, so I can see the sky glow is kind of changing on mine. Yeah, so can you not see stars? You had some clouds, so there could be some moisture down there. So maybe you could, yeah, it's probably just like, just the natural, you know, sky glow as it gets lower on the horizon, right? The sky glow is going to be worse in the light pollution, and you know, the city lights reflecting off the mist and haze, right? So. So anyways, back to on the telescope design. So where I'm at right now, with such a long coma corrector and the back focus distance requirement, the camera has to be hanging out that far. The mirrors have to be closer together. So I need a really large secondary mirror, and I'm actually missing some of the light. So this triangle is the reflected light cone, and so I'm actually missing some of that reflected light. Satellites are no problem, Myth. Don't worry about the satellites. The stacking software removes those super easily. No problem at all. Totally does not. Even like really big streaks from like airplanes mostly can get removed. Yeah, don't fret about satellites at all. So yeah, I mean, ideally this would have like an even larger secondary mirror. So, but then the larger the secondary mirror, the more you're blocking, the more the larger the central obstructions blocking the primary mirror, right? So, no, you don't have to toss those. Totally fine. The stacking software will remove those pixels from the satellite streaks, just like magic. So this is 450 millimeters focal length, and this mirror, 520 millimeter focal length. So that extra 70 millimeters, right? That's like from, you know, that's like that much longer. So that would totally alleviate that problem. And it's only slightly larger in diameter. But unfortunately, that would mean I would have to pretty much redesign this entire thing from scratch because it wouldn't fit. It would be too large. It wouldn't fit in the current. I mean, it would fit in the tubes, but it wouldn't fit through the baffling and stuff. So, yeah, it really wouldn't work. The whole thing would need to be a bit larger in diameter. So, oh, have you been tossing subs that have satellite streaks in them all this time? Yeah, you just have to use, there's different stacking algorithms, and you just have to use, I don't know, there's a whole bunch. You have to use the ones that reject those pixels. Kappa Sigma clipping, and I think is one, the name of one. I don't know. I just know to use the, yeah, no. Have you been deleting them, or have you just, if you've been just thumbing thems? If you've just been thumbings them down in Nina, it doesn't delete them, right? It just renames them. So like this one that I thumbs down, it just renames it bad. So Windsor Sigma, yeah, I know that's one of them. Yeah, Windsor Sigma clipping. Caesar style thumbs down. Does that mean you murdered them? you didn't just thumbs them down, but you thumbs them down and deleted them? I feel like I'm starting to get, yeah, a lot of sky glow here too. So I don't know how much. Last night I ran it until cool. Yeah. Okay. So if you still have them, yeah, you can just sort through them. Yeah. Right. Misadventures. Yeah. Yep. Yeah. Strangely, I don't think I've been seeing satellite streaks in my images. Yeah. Cool. All right. So you got them there. That data's still there. You just have to go through it. Sometimes I get a little delete happy, and I'm just like, not just delete, but shift delete, which is delete without sending it to the recycle bin. It's like permanently delete. Sometimes I can get a little delete happy, and I don't think I've ever deleted anything permanently accidentally that I know of, but there you go. Yeah. Yeah, so you may have a lot more data than you were thinking on various targets. The other night I ran this for until like right about midnight last night. Oh shit, boys. Oh shit. Ooh. I just got a message. He's got 2 spots. Sorry. Give me one moment here. Why am I not? Oh, that's a screenshot. I'm like, why can't I reply to this message? Because I took a screenshot of it. How's the weather going to be Saturday, boys? Hopefully the thumb drives were not Bitcoin wallets, Mazif, that you lost. Okay, so where were we? Did I close that tab? Mount Wilson Observatory. So they have the 100-inch telescope, and they have the 60-inch telescope. Where do they show? 60-inch telescope. So only 60 inches. Hey, what's up, D. Garrick? Cool, man. Glad to have you here. So this is a 60-inch telescope at Mount Wilson. You know, only 60 inches. But still pretty friggin' big, right? Look at this thing. So there's a dude I've been following on Instagram. Telescope Man. Giovanni Somoza. I never met him. He's a member of the Los Angeles Astronomy Society. Is that it? LAAS, Los Angeles Astronomy Society? And I haven't met this dude, but I've been following him on Instagram. And he posted on Instagram today that he's one of the guys that operates the telescopes up at Mount Wilson. And he posted on Instagram today, it was like, Saturday night, we're having a like pre-opening season like night. $60 per person, 10 spots available. I sent him a message. I'm like, me and my girlfriend want to go for sure. And he just got back to me. I do have 2 spots. $60 per person, 6 p.m. to 1 a.m. $120. He sent me his Venmo. So how's the weather looking for Saturday night? Garrick, am I going to be at Open Sauce again this year? I think probably not. So probably Myth, I'm almost certain it will not be a like put a camera on the telescope kind of thing. Because if it's like just general viewing, you don't want to be fucking with fucking with other people, you know? So it's like, no, I got to put my camera on there. But maybe like put a camera, like a time lapse on the floor, get some shots like this, right? Weather will be good but windy. That could be okay, because the San Gabriels, these San Gabriels are kind of block the Santa Ana's. Yeah, Garrick, am I going to be at Open Sauce again this year? I don't think so. It's probably a super long shot. So probably not. I would like to go, but yeah, I'm not planning on it. All right, so we need to look at the weather for well, actually, yeah, Chino Hills weather is going to be Saturday night's clear. A little bit of clouds 6 p.m., but the night's clear. Doesn't show clouds. Yeah. Shit, boys. It's only the 60-inch, though. I'm really excited to look at Jupiter in that. Oh, let's look at what's Jupiter going to look like that night. All right, so what we can do, check it out. We go Stellarium, and we can bring the date back to, what date is that? 29th. So go 29. And time like 6:30. And we'll Jupiter. So then zoom into Jupiter. Let's see, do we have any like any moon transits? So we'll just bring the time forward. So we'll have the great red spot at midnight. No moon transits though. No moon transits, unfortunately. But yeah, it'll be there. That's super cool. Oh, Jupiter will be set by midnight. Okay, well, we won't see in that. Yeah. Yeah, Orion. Yeah, Mars. Yeah. Mars. Well, there'll be Mars. Oh, I wonder if we'll be able to see Phobos and Deimos. I just been watching that show, The Expanse. You guys watch that show? And the Earth just blew up Deimos. So maybe we'll be able to see if it's still there. That'd be pretty crazy. Yeah. Ah, cool. How exciting. Cool. Yeah. Saturday night. We got plans. Sorry, guys. I'm busy. The Expanse was a hella good show. I'm kind of maybe 7.5 out of 10 on The Expanse right now. We're like middle of the second season. I think it's like, it's good. 10 out of 10 for your sci-fi shows is Firefly. 10 out of 10. That's the benchmark for sure. Expanse is good, not as good as Firefly. I haven't seen a lot of sci-fi shows, I guess, now that I think of it, like Battlestar Galactica and stuff. Haven't gotten into that yet. So, but enjoying The Expanse. It's fun. What I really love about The Expanse is good sci-fi is it's like the story is based on a solid established like rules and science of like the universe that they're in. And it's like the way they travel and the concepts of in The Expanse, like the people who live in the asteroid belt don't have the bone density to survive on Earth because of the gravity, things like that, and like mining ice out by Saturn, and like these are things that are sort of based on physics and the real world. So that's pretty cool to see. So and I'm starting to get kind of some streaky images here. I wonder if I'm just kind of, I might want to throw some of these away. Prime rib. Woof. Now, is that real? Is that prime rib or is that just rib roast? Because I've learned recently there's a difference. All right, so these stars are starting to get kind of elongated. I don't know if I want to keep these or not. Yeah, I don't think I like. I think I'm going to toss that one. Yeah, maybe. Well, I'll just leave it. I think it'll. Boneless prime rib steaks. Damn, boy. Garlic sauteed green beans. Oven roasted mashed potatoes. I'll be right there. Be right over. Definitely getting some signal in there. You hit the grocery store today. Right on. You'll bring the steaks. I like to hear that. I like to hear that. All right. All right. Well, guess we won't get a new moon trip this month, but get to do something maybe even more special and cool. So that's very excited to do that. Very excited for that. Yeah. How are we looking here? I don't know if I should keep. I guess I just keep shooting, and yeah, it's kind of weird that I'm like all getting some streaks and stuff, and yeah. Maybe it's not too much different than what I was getting. April new moon, yeah, dude. Yeah, hopefully that'll be good. I was gonna maybe go up to Mount Pinos tonight just for one night. But Dan, he decided his truck is still having issues with his truck, so he didn't want to head up there, or maybe he was just not. It wasn't possible. So yeah, gosh, we've had such good weather for like the whole last week. Has been really great. So yeah, but just not getting it now, I guess. Not getting it when you need it. And my guiding is starting to get a little poor. I'm sure that's just a result of poor seeing as the object is getting lower on the horizon. Definitely getting some signal in here, but yeah, I think I'm gonna need a lot more to really make a difference. To make a real difference on this image. But I'll just keep getting what I can get. I'll probably bring the telescope in tonight. After this. Yeah, chasing that dragon. Yeah, that's how it is, isn't it? That's how it is. Well, it's good you can do at least something from your home. So. All right, I think I'm gonna wrap this one up. Feeling pretty hungry. I think I want to get a midnight snack. And my friend Chill Maze is on streaming, so I think we should go raid Chill Maze. And it's almost Myth's dinner time, anyways. So, looking very forward to Saturday now. Maybe I'll do another stream. I need to do some daytime streams, some CAD stuff. So maybe we'll do that during the week. And yeah. So anyways, I'm feeling the hunger. And so I'm going to go do that. And we're going to go raid Chill Maze. Thank you guys for being here. I appreciate you. Fun times always having you guys around. I'm still working on a YouTube video. That one's just taking me a while to get going. But yeah. Anyways, hopefully I can get that done. I should be able to get that. I should get that done tomorrow. I should get that video done tomorrow. I should do that video tomorrow. Get that finished. Chill Maze is flying a Microsoft Flight Simulator. Fun to hang out on his stream. He's a cool guy. He kind of took a break from streaming for a little while. Good to see him back. He's flying a very cool looking airplane. This thing is like a race car. This thing looks dope. All right, let's go raid, chill, maze, and I'll see you guys later.